In this video, I'm going to go through the constructions portion of the geometry review. This is in packet 3. So the first thing we're going to do is construct a perpendicular bisector of each of the segments here. So that does two things. It's perpendicular, so it's going to make right angles, and it's a bisector, so it's going to cut it in half. The first thing you're going to do is put your compass point on either of the endpoints. Open your compass up to some point that's past the halfway mark of the segment, and draw an arc. Keep that same arc length and put the compass on the other end and draw that same arc. Mine moved a little bit, but let's see if I can get this again. And you'll notice you've created two intersection points. So if you connect straight on through, arrows at the end because it's a line, you should notice that as long as your compass didn't move too much, you've got a right angle right there, and that this piece should be approximately the same length as that piece right there. So you would again do the same thing for B, only instead of it going this way, it's probably going to go some way that way. For number 6, I want to construct an isosceles triangle with this length of a base and these length of legs. So anytime I'm drawing a triangle, if they don't give me some place to start, I'm going to give myself a place to start just by drawing some sort of segment. So I'm going to measure the base with my compass by just opening up my compass until I could see the end point of that base in the hole. Tighten my compass, and I'm going to copy that distance down here. So this right here is the length of my base. Now I know my legs are going to come up here and here, so I'm going to measure the length of my legs. Again, by opening up my compass until I could see the point inside the hole, tightening it, and I'm going to connect the legs. So I'm going to put one of them over here, and the other one at the other endpoint up here. So now I've created an intersection point up there. That's going to be another vertex of my triangle, and I can connect the 3 points. So as long as your compass didn't move too much, these should be the same as this, and your base right here should be that length right there. For number 7, using only a compass and a straight edge, construct the angle bisector of angle ABC. This one's actually a pretty quick construction. You could put your compass on the vertex right there, vertex B, and swing an arc of any length as long as it goes through both sides of the angle. So what I'm going to do now is I'm going to put my compass point on either of those intersection points, swing an arc over here, keep that same length, and swing an arc over here. You'll notice I've created an intersection point here, so I'm going to connect that straight on through, and there you go. You have the angle bisector of that angle. So this angle and this angle should be the same. Number 8, use a compass and a straight edge to construct an inscribed square. So the square is going to be inside the circle, but all 4 points of the square are going to be touching the circle. So I'm going to start just by drawing a diameter. So I'm going to just draw some segment that goes through the middle of the circle. Now I'm going to use that first construction that we did, the perpendicular bisector, by putting my compass on one end of the diameter, drawing an arc, putting it on the other end of the diameter with the same length, I haven't changed my compass, and drawing an arc again. Again, these should have been extended a little bit further so that they intersect, and I'm going to connect straight on through. So all I did was draw a diameter and then a perpendicular bisector. I now have 4 points. If I connect these 4 points, again, this is going to be a little off because I missed with my compass, but you should have a nice inscribed square inside that circle there. For number 9, we are going to copy this triangle right here, ABC, or this is XYZ, and I'm going to copy it down here, and I'm going to call it triangle ABC. So I'm going to do it like I did before. I'm going to give myself a place to start. And I'm just going to measure each side length. So I'm going to measure x, y, until I could see that vertex in the point of my compass. And I'm going to copy that distance down here. So let's call this A, and we'll call this guy B right here. Now, xz is going to have to go somewhere over here, and yz is going to have to go somewhere over here. So I'm going to start by just measuring those two lengths. So I could see it pretty well right there. So I'm going to copy it. Again, I know my point is going to be somewhere in this vicinity, so that's where I draw my arc. Now I'm going to measure YZ, and notice how much I'm moving my paper just because it helps me a lot with the compass. It makes it easier to measure and see it more precisely. Okay, I'm going to put my compass back on point B, and I'm going to copy that side length here. And this is about where I expected my point C to be, because it's around where Z is right there. I'm going to connect it, and now I have the triangle that is the same or congruent as XYZ. I've got triangle ABC right here. And it says, based on your construction, state the theorem that justifies why triangle ABC is congruent to triangle XYZ. Well, I just copied all of the side lengths, so you can make a side argument that all these sides are the same, so these triangles should be congruent. Number 10, construct the line of reflection. So this one is also a quick one. You can connect any point with its image. I'm going to choose R prime and R here, and just do the perpendicular bisector of that segment. It doesn't matter if you choose S and S prime, R and R prime. All of them should work. So I'm going to open up just past half, draw an arc, swing it around, draw another arc, and connect, missed it there, straight on through. You'll notice that this looks like I just folded the triangle over the line there to get a congruent triangle. And you could do that for any of these points and you'll get the exact same line. For number 11, we are tasked in constructing the median of AB. So the line, or the triangle line that goes from the vertex to the midpoint of the opposite side. So we're going to need to find the midpoint of AB. So think back to that perpendicular bisector. It bisects a segment, it cuts it right in half. So if I do the perpendicular bisector of AB, I'll be able to find out where the midpoint is. So that's the first thing that I'm going to do here. I'm just going to do a perpendicular bisector, and we'll say that's about the midpoint. I'm going to label that M, and I'm just going to connect it straight to the vertex. So that's a median to AB because it goes from a vertex to the opposite side and touches the midpoint of that opposite side. If I instead want to construct the altitude of a triangle, now it doesn't say which one, so I'm going to construct an altitude from B to AC. Remember that an altitude is perpendicular to the opposite side. So the first thing I'm going to do here is I'm going to put my compass on point B, and I'm going to draw an arc that goes through the side AC twice. So make sure that you could swing your compass and it looks like it goes in and out. So something like that, so that you've got those 2 points of intersection. Now what I'm going to do is I'm going to put my compass on both of those endpoints and just swing an arc without changing the length of the compass. I can connect B straight through that point right there, and you have constructed the altitude. And you'll know if you did it correctly because that'll be a right angle right there. This is the exact same construction as when we're drawing perpendicular lines through a point that's not on the line.